So welcome and thank you for joining us for another episode of the Jane Irrigation Training Series. And today we're going to be talking about what I think is very important to the future of agriculture, and that is controlled environment agriculture. And I think it's so important because I think, as we all know, we're trying to grow more crop per drop. We're trying to feed more people using less inputs and less resources. And I think this might potentially be a big way or a big help in achieving that goal going forward. And why I thought it was so important to all of our audience members is that, number one, it does provide a solution. And I think, water issues across the world are going to be solved by many different solutions. But I think this is one of the big contributing solutions that we're going to see. And then number two, we have three gentlemen today from Vertical Agritech, who are some of the brightest young minds that I've talked to about water and agriculture in a long time. And they're so exciting to talk to, and I'm really glad you all get a chance to hear them as well, because what they bring is a lot of knowledge and, more importantly, a lot of passion for what they're doing. And I think that's so important. So our first guest is Ethan Moran, and he was a founder of Vertical Agritech. He grew up in the Central Valley. He's actually an attorney as well, and has a BA from UC Santa Barbara. So a lot of great things right there about Ethan. But as I said before, a great passion for what he's doing and what's happening as far as water and more sustainable growing. And then joining Ethan as well is Nathan Baird. He's the Vice President of Engineering at Vertical Agritech. He's a real mechanical mind, real engineering oriented, and more importantly, you can see his desire to share his knowledge about what they're doing in a solutions oriented way that I think is great. And I think you'll all enjoy that. And then finally, Ben Kaufman, who's joining us from New York, is really interesting as well. He's been a chef, he's been a sommelier, he's done a lot of work in agriculture. We were talking yesterday and they said, it's about time that we make people that are growing food as popular as the people preparing it, right? Wouldn't it be great if we knew growers and we knew them like we know celebrity chefs? Because really, if you think about it, the celebrity chefs wouldn't have anything if the food wasn't there and properly grown. So we talked a little bit about that. So anyway, I think you guys will really enjoy the conversation today. And, starting off, I just wanted to ask Ethan right off the bat, I read yesterday, I think it was yesterday that I saw that quinoa, one of my favorite seeds, right? They said it's so 5 years ago, it's kind of a fad, it's gone. And then I started to think, I'm hearing a lot about controlled environment agriculture right now, but is it a fad? Is it something that's just going to be around for a while? And what are your thoughts about that?
Yeah, so there's been, I'll get this started here. So there's been a lot of hype around controlled environment agriculture in the past couple of years. There's the AeroFarm SPAC deal that fell through. We definitely think that in terms of the Gartner hype cycle, we might be headed or into the Trough of Disillusionment, but that's really the best time to build. We think that CEA is most important for developing the technologies that can be scaled, not just in super controlled environments, but also for greenhouses and hoop houses and even outdoors. So some of what we'll talk about is like the machine learning aspects and the precision controls that are going to be able to be transferred from the CEA industry to outdoors. But generally, I think that CEA, of course, is not a fad. It's going to be around for a long time, but we're just kind of reaching an inflection point where there's so much money that's being poured into it, and the people who are setting up these vertical farms are not traditional farmers. So we'll talk a little bit about that as well.
Yeah, that was one of the things I think that's so exciting about it, is it's really attracting a whole new audience to farming, right? A younger audience that's interested in technology and using technology to be more productive.
That's right. So should I get into it?
Yeah, let's get into it.
All right. So we're going to go over the CEA landscape here, and we kind of use vertical farming and CEA more or less interchangeably. But the vertical farming industry is projected to be 19 billion by 2026. And we think that the growth and investment in this sector will be a rising tide that lifts all boats in the agriculture industry. And this is because vertical farming, or CEA, is comprised of other key ag tech industries like the hydroponics market, for example, which by itself is projected to become an $18 billion industry, up from 9.5 billion in 2020. So a lot of growth there. And despite these opinions that the CEA industry is headed for the trough of disillusionment, like I said, I think we think that this is the best time to build. The government governments are supporting and generally supporting CEA, and there's potential for new concepts to emerge in terms of landscaping or installations in high-end homes or businesses. You've seen grow walls and that type of thing, and then also like city beautification and reconsideration of what green spaces are. And something that I think we'll talk about at the end, Nathan will talk about, is who are the modern farmers, kind of like you mentioned, Richard, is like, wouldn't it be cool if we could put farmers to the same degree as chefs? And something that you mentioned, Richard, yesterday that I just added in here is there's a change in the way farming is done. So you're not making a commitment to a large plot of land for a lifetime or generations. It's a building that you could kind of move away from or lease out and operate from a different place. So just to put some things into context here, drip tape was developed in the 1960s, and that was kind of in response to regulations. And so I'll talk about how regulations are pushing this a little bit. But to frame things here, that the iPhone 1 debuted in 2007, which was 15 years ago. So my claim is that the iPhone is just as important to the ag and the food industry as something like refrigerated trucks were in the 1960s, because agriculture is an industry with long-term investments, and these types of technologies take some time to be used in and utilized properly within the industry. But if you consider, 15 years after refrigerated trucks, McDonald's began its rise to become one of the most successful food chains in America, and that's largely because of the refrigerated trucks and kind of the technology around that time. So modern farming is right now only adopting and learning to use the iPhone and beginning to leverage technologies like Internet of Things or IoT technologies and connected devices to their full potential. And right now the focus is on gathering more information. And with more information, farmers are going to be able to focus on the quantity, not only the quantity, but the quality of their yields as well, in a lot of new ways that we'll discuss. But there's still work to be done in this space, and in terms of being able to display all of this new data that we're collecting in ways that can produce better and more efficient and more sustainable food supplies. So this is kind of the layout of what we're discussing. So we'll start by talking about how CEA emerged and where the industry sits currently, and then we'll analyze the industry and devote some time to discussing some of the problems and the barriers for CEA to overcome. And then we'll conclude by offering some examples of opportunities that exist in this space, and we'll make some predictions about the future of CEA and where we expect the most growth. And after each of these sections, we'll break and feel free to chime in with questions during the slides, but we broke it down so we can break at the end of these sections.
And I just want to mention that we do have the chat and the Q&A open. So if you have questions or comments, put them in there, and I'll get them to the panel when appropriate.
All right, Ben, take it away.
Hello, everyone. Thank you for joining today. So quickly, just briefly, as it was mentioned before, I used to be a chef. So if I talk really fast and I cut through, just give me a heads up on it. I like to be efficient and fast. So lead up to CEA, how did we get to the point that we are now? And it's very important when you look at this, we're really talking about the past 100 years in agriculture, when we're talking about this aggressive change of how we viewed agriculture and sustaining humankind. In the early 1900s, leading into World War I and World War II, we had the industrial era, and that is where we saw the major transition shift into a different style of agriculture and more of a monoculture system. We also saw globalization on the first realistic scale at that point in the world, and it became more about how can we grow things in abundance? How can we preserve them efficiently to then ship them to other parts of the world to sustain our citizens? That really changed how we treated agriculture. And it wasn't until about the late 50s that we started to go back into more of the origin story of why we do what we do. In the late 50s, something called cells was being researched by NASA. It was the first real iteration of a controlled environment agriculture. It's a fully closed system. You may have heard of biodomes before. And that was the real first introduction of sci-fi or science fiction into how we discuss modern agriculture. Along with that, we started to see changes in the way people consumed food and asked for food. In the 80s and 90s, there was a huge health shift, along with a much more outspoken younger generation that wanted to be heard. And we saw consumerism starting to change with that as well. And that started going more towards cultural integration on a global scale. Having exotic or ethnic foods, especially in the American market, became popular again. Being health oriented, and i.e. with health, we're talking about fresh produce, greens, more vegetable focused diet again, along with abundance of, yes, still meat. The way we treated agriculture started to change even more. And then we find in 1999, 2000, there was a Columbia University experiment done by a bunch of students to see if they could feed New York City using only rooftop gardens. Unfortunately, they found that it could barely feed about 2% of New York City's population at that time with rooftop gardens. The professor at the time put forth a proposition of why don't we move it into these abandoned buildings in New York City, which is where I grew up. It's something I grew up around. The idea of urban gardens first started in the 80s in the neighborhood that I spent most of my life, Alphabet City, Lower East Side. And that's where we've got the first term of vertical agriculture and modern agriculture. At that time, sci-fi was still a major component of it. We didn't really see the application of developing modern technology to bring feasibility to these concepts of new agriculture. And then heading into the 2000s, we start to see now at a rapid scale, technology integration becoming possible and being talked about. We see a path to feasibility for these sustainable and holistic styles of agriculture existing now. And we've really seen in the past 20 years, a huge shift towards trying to make that happen. But as we mentioned before, we are plateauing slightly, where we still see it as tech has certain limits and we need to be science fiction based about it rather than practical about it. And the practicality is, how do we integrate this to make efficiencies in outdoor growth while taking advantage of urban agriculture at the same time?
Ben, a couple questions here I just wanted to ask. So one of the things that is concerning, right, is that, well, as you mentioned, it could feed maybe 2% in New York City. A lot of people think this is on such a small scale that it's hard to imagine it making a real impact on food.
Yeah, so I mean, there's been a lot of development in that. And, one of the first steps was in that experiment alone, where they said, stop looking at just rooftops, look at the true acreage that we have in vertical architecture. So, in New York at that time, we had a massive amount of empty space, warehouse space. And that was the initial answer towards it, was why don't we fill those? And you see around the world, you see in Paris, they've filled old subway stations and the basements of projects with controlled environment agriculture. In London, most of the top tier restaurants are served by an underground farm. And we have that throughout the US as well. But even more so, it's what CEA offers for the efficiency and the output of outdoor agriculture as well. And that's something that we get trapped in indoor agriculture when we talk about CEAs. We don't often talk about the crossover into commercial and traditional agriculture with this impact that CEAs can have on that.
And then another thing that people wonder, right, is they think maybe that CEA is just camouflage for growing cannabis indoors, but it sounds like it's a lot more than that.
Yes, it's much more than that. I mean, as we'll talk about a bit with my personal history with the CEA business models, I went to Cook College. I wanted to be a conservation biologist. I wanted to do ethology for my entire life. And a lot of the research that's led up to the agriculture we have now is about sustainability and how we can be the prime species on the planet, but coexist with a pre-existing ecosystem. CEAs are really that path forward to finding that eco balance. So it's much more than just hype crops, which, cannabis is making a lot of money for everyone. It's really bringing a lot of attention to agriculture, and that's an amazing thing. And in hemp, there is a lot of uses for hemp byproducts, but CEA is much more than that. It's involving all agriculture and commercial agriculture, especially.
Yeah, awesome. Thank you.
Yeah. So as I was just saying before, with those wonderful questions, so with farming, I actually got into farming because I worked at a farm in high school, and I worked in Kansas on a monoculture farm that focused on purely corn pretty much, and livestock as well. And that was the first time that I ever saw cycle grazing, and the concept of large scale cycle farming first came to me. And a lot of challenges for farmers is impact of sales in comparison to acreage. And margins are tight. So with having something that allows efficiencies for a polyculture growth system on a farm, multiple vegetables, herbs, mushrooms, having growth and product to sell year round, farmers are going to see a much more efficient margin in COGS with this business model, along with use for possible acreage that's being turned over. Cover crops, there's been a slow transition, unfortunately, to profitable cover crops. CEA offers an amazing opportunity to rapidly regenerate your soil with low acreage impact, and also have profitable crop at the same time. And that is driven by the hardware and the software. So within the hardware, there's a lot of components, standard components that are useful on their own and useful together as well. This offers, again, in the CEA business model, an opportunity for a farmer to have another revenue stream. The scientists and engineers and technicians behind the development of this hardware need farmers' input to really make this practical and feasible on a large scale. This offers an opportunity for farmers to then earn another wage on being consultants on the development of this hardware. Along with the software as well, software is another language for a lot of us in the agricultural realm. It's something hard to transition to, and that's going to be a major part about this is the user experience for agriculturalists. So having the software developed where generational farmers can easily transition to it is going to be an important part. And we're going to need the input of generational farmers in order to make that feasible, along with farmers now have the possibility in their future of not being tied to their land. You can run your farm that's 1,000 miles away from you with the use of remote controls, remote monitoring, and you can actually give the proper information to your consumers that it's still your handiwork and your experiential skills that are making this happen through blockchain. And finally, then there is consulting. This is, again, a very unique language. We're going to need translators to make this applicable on a large scale and on a global scale rapidly. So jumping into CEAs now in the early stages of it only offers new career opportunities for the next generation of agriculturalists and for the current generation of agriculturalists as consultants for the transition. And then within CEA Technologies, there is an immense amount of technology behind this, and that we are working on to make it even better. It's very hard to get lost in that, and we're going to pretty soon get lost in that. But right now, I just want to cover sort of 4 key elements of it. Lights. So with lights, we are talking mostly about indoor agriculture. It was very high cost and so unfeasible heading into the first origins of indoor growth and indoor agriculture. Now with the creation of LEDs and the understanding of light spectrums and output of that, we have a much more efficient system towards lighting, and we have much better output from the lighting systems that we use now. HVAC is going to be another very important thing. We are talking about a fully controlled environment. with that, air is a key element of it. In my operations with mushrooms, my father and I started while I was in college, Shibumi Farms, which grew in the first 5 years, being one of the largest mushroom farm operations in America. The airflow, the HVAC unit, and the O2 leveling were some of the most important elements of our fruiting chambers, which is most of the production of indoor mushroom growth. So we really lived and died by our airflow and our filtration and balancing of that. So that is going to be a vital element in indoor agriculture. Irrigation controls are, again, incredibly important for that, and we've made major headway on that. You're talking about, right now, it is a limited item. It is going to be a limited item heading into the future. We have a limited resource with water, and we need to optimize the use of it. We are often, depending on where you are, especially like California, you will be allocated your level of water for agriculture per year, and you need to make sure that you can afford that amount and that you can grow the crops you need to with that amount. Using controlled and atomized irrigation systems, you're able to optimize your output with limited water resources. And finally, you're looking at the tech side of it, the actual control boards of it. And that's really where we see the integration, the necessity of integration of programming and engineers within this agricultural realm. This is a lot of data input and data output to be done on a grand scale. You're going to need the specialties of modern tech to be able to manage that and to translate it into usable data outputs.
Wow, talk about opening it up right away to really, you're only limited in opportunities here by your imagination, right? This is a whole lot of great information, and I'm sure you have a lot of people, thinking right now. So we had those first couple questions come in, but I think we're ready to move to the next section now.
Okay, sweet. So I'll be talking about the state of where we are now. So right now the focus is on precision control and the transferability of knowledge between operations, and then also between grower and consumer. So right now, indoor farmers really want more control over their grows, but most aren't interested in complete automation, in the sense that farming is an art. If you look at some of the cannabis facilities, there's a lot of people still hand watering, for example. So being able to just have the right monitoring to know that I hand water about this much, and what does about this much mean, so that I can replicate it and get consistent results, is kind of where we're at now. But cannabis is really driving this, and you're going after something with different with cannabis. So even when we're talking about light spectrums and the research that's going on there, which is a really big field, you're trying to grow this crop for the psycho effects, as opposed to the taste, or sometimes the appearance and crossover. But this is the consequence of cannabis driving the industry. The research is trending toward using a lot more machine learning to understand the effects of things like organic fertigation and the light spectrums, and how those inputs affect the phenotypic expressions of different plants. And I was just reading, like, there's cutting edge stuff like electroculture for plants, where this Chinese group is saying that they are applying electric current to plants and it's increasing yield. So there's a lot of it's basically, in the indoor farming space, a lab to better understand plants and plant treatments. But what we need to do right now is collect more accurate data that actually means something. So how does this data make the farmer money? And you need actionable data on what that rate of return is. So for year-round cycles, we're talking about, as opposed to seasons. But even in terms of the revenue potential that you could generate, does it make more sense to grow pumpkins year-round, when pumpkins really are in high demand, mostly in October and November? So being able to assess the data that's going on in the market and match that up with the data that's going on in the farm is something that machine learning can help with. And also it can help with focusing on replicating growing conditions from one CEA facility to another CEA facility. So there's a lot of focus also on automating mundane tasks that require some level of human intelligence, like harvesting and properly harvesting it, training a machine to pick and harvest a plant that's a delicate plant, maybe it's a baby green or something, and not have that machine crush it, and to be able to identify different types of plants as well. So there's also the issues with indoor farming capitalizing on certain terminology that's typically used in outdoor farming, for example, organic, and there's a fight over the use of the term organic and whether it can be used in soilless operations, because organic typically has to do with the quality of the soil. And then there's also attempts, and this is what we are focused on as a company, is to more efficiently transfer knowledge about techniques and market demand, which is important for scaling this up and potentially building in franchising models. So talking about a little bit of the regulations that apply, fortunately the regulations and the legal industry moves even slower than the farming industry does, but in general these regulations are pushing us in the right direction. So we have the Office of Urban Agriculture and Innovation that was established by the 2018 Farm Bill, and that office manages a competitive grants program to incentivize people to become urban farmers. It's also establishing a federal advisory committee and the Farm Service Agency county committees that are focused exclusively on urban agriculture, and also developing policies and resources to assist people in the space. And then like in 2013, the California legislature passed a bill allowing county and city to establish urban agriculture incentive zones to support local food production. But the regulations that are going to apply, they are going to depend on the size. So we're thinking of this as a more modular approach, because we know that, Silicon Valley getting into this, they have the kind of move fast and break things model, which doesn't really work in ag. Perhaps that's part of the reason why the AeroFarm SPAC fell through, which that would have valued the company at 1.2 billion. But according to a census, 70% of farming operators agreed that CEA is susceptible to excessive greenwashing. So those are some of the regulations that apply. I know probably you're interested in water. There are people listening, you're probably interested in water. So it's in CEA, it's not so much a concern with the amount of water, because CEA can typically use 70 to 98% less water than traditional ag. But it's what do we do with the water after we've ran it through our system. So wastewater is really the biggest concern in this space. In terms of how the size of your operation as well, obviously, if it's a really big operation like these Bowery or Plenty, there's considerations about zoning and getting the right permits and assessing the environmental impact that people who want to replicate that will need to watch out for. What I think is really interesting is the food safety regulations. A lot of the food safety regulations have to do with elements of the supply chain that might be cut out by bringing farms into cities. So a lot less of the handling and the packaging, and a lot less distance, and in terms of the transport. So there's the Food Safety Modernization Act, which is covering this, and the regulators are more concerned with what you're growing, kind of how much money you're making from produce sales, and where you are in the supply chain. So there's issues to be resolved there. Obviously, there's energy usage, and we could talk, about solar and the potential for solar to offset some of these energy costs, especially when it's in the city. And then if you're dealing with cannabis, there's specific regulations that apply. We can talk about that if anybody has questions. I'm not going to go super into it. But the really interesting thing is the transition of the labor force from unskilled seasonal labor to full-time employees with maybe software engineering or biology backgrounds. And this kind of provides this opportunity for the younger generation to get into farming, where, you know, talking with a lot of farmers, and people, you know, my age who are from generational farming families, they don't typically want to get into farming. They might want to go be, especially small farmers, like we're talking with the Hmong farmers here in the Central Valley. And the people that are my age kind of want to go into, they don't want to go into farming, they want to go into software and engineering. So it helps that the regulators are pushing us in the right direction in terms of grant programs and incentive programs, but the industry has some work to do in being able to connect how, if you become a software developer, you become an engineer, you can still work in the ag field and actually have a more productive farm. And then I kind of already discussed the labeling thing with the fight over the term organic and stuff like that. So in terms of the barriers to adoption here, obviously farming is a long-term investment, and so the changes that are required might seem overwhelming, but this transition has been incremental, like Ben said, you know, kind of over the past half century or so. There might be some hesitancy from people that are in the industry to invest in the technology because it's expensive and they're not exactly sure how they're going to use it or how it makes them money. But according to the CEA census, 49% of CEA operators had 0 years of prior farming experience. So there's a lot of opportunity for people with generational knowledge about how to farm to get into this space and have an advantage. But in that same census, they found that 73% of the respondents would opt to change the equipment, the technology, or the crops that they selected if they could go back in time. So the importance of doing your due diligence, not just on what technology you're using, but what crops you're going to grow is really important. So the hesitancy generally from the farming industry is a good thing, I think, but it's time to make moves at this point, especially with the industry kind of in a plateau period. These are generally the best times to build. So being able to understand these new business models and get insurance for this. I mean, the insurance should generally probably love this industry because you're not dealing with unforeseen weather events that can wipe out, you know, acreage. The subsidies are applicable in a lot of cases that traditional farming would be familiar with. But how do you balance the risks that are associated with the benefits? So I wanted to give this example of, or I wanted to mention that there's a lot of technologies that can be applied from other industries into this industry that may be more familiar to farmers, but they're hesitant to apply it in their operation. So this example is like in aeroponics technology, you know, atomization has been used in the medical and aerospace fields to distribute fine particles. That's tried and it's been tested. It just hasn't really been applied in agriculture. And another example is like, my company was in the Valley Ventures Accelerator program here at Fresno State. One of the other ventures in the program had created these water pearls, which are a super hydrophobic bead. That's a solution from the oil and gas industry. But applied in CEA, it reduces evaporation to prevent abiotic stress and prevent humidity from being released into the controlled environment. So these are already which you know reduces costs associated with dehumidification. There's less disease. So there's solutions out there. The trouble is, and the barriers to adoption are feeling comfortable with how to apply them in agriculture. So that's the next break here. And if anybody has any questions or thoughts before we move on.
Yeah, we got a couple of questions here. One comment I wanted to make. You mentioned that a lot are new to growing who start these ventures. I know lettuce grower up in Salinas, and he says, I've been growing for 30 years outdoor. I'm going to take that information, that experience, and transfer it to indoor, and competitively, I'm going to have a big advantage over everybody else. I think it's interesting that we're seeing both. Now, you mentioned water, which is a big issue for the audience. And I think about a lot of these controlled environment agriculture facilities are in municipal water districts. Are they paying municipal rates, or do they get a special rate for water if they're growing in the city?
So that's determined on a city by city basis. And there's an example of, I think San Francisco, they offer a discounted water rate for urban agricultural uses. So one urban farming operation in San Francisco received financial assistance from a local foundation to help subsidize the cost of hooking up to the municipal water supply. But that's part of where I think if farmers are interested in doing this, they can go to their city or their county and those regulators, and there are incentive programs out there from the federal government and from the state government that maybe some of these people, that the city politicians aren't necessarily aware of, but it's on a city by city basis.
Right. Okay. Well, that's interesting and smart thing to check out first, right? And then in a state like California, this comes in from one of our viewers, where land prices and especially construction costs are so high. Could something like this ever replace traditional farming methods in terms of costs?
Yeah, we were just talking about this. Ben, do you want to take that
Yeah.
one?
So I mean, there's a lot of ways that we can approach this. I think one of the easiest answers to make first with this is when we're looking at starting a farming or even a landscaping operation, you're looking especially at investment cost over time. You can't start a farm overnight. When I started in agriculture, I focused on bioremediation, regenerative agriculture, and permaculture. The current timescale to start a regenerative farm or sustainable regenerative farm is 5 to 10 years for real actual output. With CEAs, we're talking about really cutting that time down. You're going to be able to make profit on your seeds in the first year. You're going to be able to start selling your produce, and then you're going to be able to integrate it to your outdoor operations. So you don't have to cut all your acreage, but more minimize it and optimize it so that you can actually have better profit over time. So yes, I think, construction costs exist in no matter what we do in agriculture. To turn over a large acreage plot into usable land costs a lot of money. To turn 4 acres into spin cycling controlled environment agriculture will cost about the same initially, but you have much lower real estate costs, much more lower real estate management costs, and you have a sooner estimated time to sales of production and return on your investment.
We have another question right along this line, and that is, how big does my facility need to be to turn a profit?
Yeah, and I see this other one about the what's the story behind these baby shaped pears, and I think that those are kind of they're in the same vein or same category here that we can address. So like, how big do the facilities need to be? You can have a small operation that's doing something highly specialized, and if you have a market to it or a market to sell that product, then the facilities don't have to be very big to be profitable, but it depends on what you're growing. And so the story behind these kind of baby shape, the pears here, and it's more about the control over how you're growing. So like the way that those pears are grown is they have like these little casts or molds that the fruit grows in, and these sell for a lot more money than a normal pear would. For obvious reasons, it looks cool. It's really big in Asia right now, and it has been for some time. But there's additional ways to make a small facility profitable, depending on where you are. So for example, Fresno chilies in Fresno, or in some place that the data is showing that people really like Fresno chilies, and they have to be trucked in or shipped in. Being able to service that market and being able to design a facility that allows you to grow Fresno chilies for 3 years and then something else for after that period that makes more sense is some of the benefits to being able to optimize the operations that we're just starting to explore.
And to add to that as well, so I mean, we were talking about the change in theories and methodologies behind agriculture and how tech is catching up to it now. Spin farming and small acreage spin farming really started to show up in the early 2000s when CEAs were first starting to be discussed as well. But you still have a major hurdle to jump with spin farming, and that's the seasons and the outdoor elements. You're going to only really have maybe about 2 seasons of profit, with 2 seasons of just trying to minimize cost while waiting for the next harvest season. With CEAs, you now have 4 seasons of profit, and the growth zones, though I think they should still matter, they don't matter as much. So like when I started with Shibumi Farms, we were in zone 7 of agriculture, but with a lot of our mushroom strains, we were growing tropical strains, pink oyster mushrooms, which are from the Southern Hemisphere. We were growing Mongolian king oysters, which are from a much colder atmosphere than New Jersey, Lambertville, New Jersey. So you have a lot more opportunity in the variants of the flora that you're actually investing in and selling and growing.
Yeah, and so then one last question from our viewers, and it has to do with, is this all soilless, or are people growing indoors in soil?
There's different substrates. I mean, it's typically soilless, but there's problems with bringing soil in and introducing it into a controlled environment, contamination, and then what do you do with the soil when you're done with it? It's kind of the same issue with wastewater. So typically they are soilless, or they're using some kind of purposeful substrate, whether it's hemp or something else, jute mat, or completely soilless, no substrate at all.
And I will say, as far as mycelium goes in CEA agriculture, we've progressed from doing plugs in wood inoculation and in the outdoors to now substrate-based growth indoors, and that substrate is actually top grade fertilizer after about 3 flushes. So you have a whole nother revenue stream, and you have zero waste because these mostly seed or hay-based substrate formulas are then prime fertilizer for outdoor agriculture.
Wow, that's really interesting. Pretty fascinating too. And I see a couple of people are commenting too that they're growing in clay beads and some in fish waste nutrient water. So there's a lot of options here, right?
Yep.
Yeah, the agriculture stuff's very cool.
All right, Nathan, you're up for the next section.
All right. Well, hello. My name is Nathan Baird. I'm the Vice President of Engineering, and I'm here to talk to you. We're first going to start off with a little bit of precision control and monitoring, and that's actually going to lead us into a conversation about machine learning and hopefully take us to a spot where we talk about how that's going to affect people moving into the future. So to start off with the opportunities in precision monitoring and control, first, precision monitoring is expected to grow into a $16.35 billion industry by 2026 or 2028. Sorry, with projects like Jane Logic and their smart irrigation controls leading the way into this sector, actually. So what is precision control? It's more or less it's about being able to get feedback from your crops and to then be able to take precise action on that data that you're receiving. All of this is about creating value through efficiency. As everybody knows, the costs of your inputs are only going up. It doesn't matter whether it's water, whether it's whether it's water, whether it's fertilizer, whether it's labor. Everything is going up, and managing these is becoming increasingly important as we move forward into the future. One of the areas actually that that precision monitoring is going to be able to help the industry as a whole is actually in the area of resource management. And so the example I'd like to give you here is actually a study that was conducted by Michigan State University, and it used much of the same data that you're actually able to collect from the Jane Logic platform. It uses a combination of historical data, satellite data, as well as in-field monitoring equipment. And through this evaluation, they estimated that American farmers are wasting $500 million a year over fertilizing unproductive lands. So this is like an obvious area where farmers are able to use this data to kind of help safeguard their investment. The other side of this is in things like notifications, right? So if you have an hydroponic farm and a pump goes out, that can be the end of everything, right? But with these kind of systems, you're gonna have feedback on that. You're gonna have flow rate sensors, you're gonna have humidity sensors, and you're gonna be able to get a notification that's gonna let you make better decisions and be ready when these sort of catastrophic things kind of happen, right? Now, the other side of this is the precision controls, and this is going to come in the form of irrigation and other technology that's being introduced into this space that's going to allow you to take those large data sets and make really precise controls. And that actually leads me to my next topic, which is machine learning, right? So when we talk about machine learning, the best analogy I can give you for this one is, as you can imagine, we're getting a lot of data really fast, and it gets pretty easy to drown in all this data, right? You don't know what to do with it. It doesn't make a lot of sense to a lot of people. And the best analogy I can give you is the traction control system in your car. Now, if you have an all-wheel drive car, roughly 1,000 times per second, you're being updated with a frictional coefficient at each of the 4 tires. Now, for your car, this is an incredibly important piece of information, right? For you, it doesn't mean anything and you can't do anything with it, right? And in a similar respect, that's where we're at with machine learning in plant science. So one of the things that we're starting to find, and this is where I like to think about the symbiotic relationship between indoor agriculture and outdoor agriculture, and where these things are going to intertwine moving into the future. And one of the biggest areas is in the area of plant breeding and understanding these complex systems, right? So there's actually a paper, it was a longitudinal study that was released in iScience last year in January. And they talk about, they take an overview of machine learning in agriculture. And one of the things that researchers are starting to be able to do is, if they know the genotype of a particular seed, and they can get enough data about the environment in which that seed is operating, they're starting to be able to tell what sort of gene expression we are going to see in the real world, right? Which I don't know about you, but I find that personally just insanely fascinating, right? So the reality is, though, is that a lot of this data that you're going to be collecting, you're going to be collecting all of these things. This isn't something that a person can do, right? This isn't something that a person can digest. It's not even really something a person can understand. Many of the machine learning algorithms are what are called, what we would like to refer to as unstructured algorithms. And they are looking for unforeseen patterns, right? That we can't make much sense out of. And you have to be a computer to do that. So here's the beauty of these whole systems and where this kind of intertwines, right? If we know something about the genome of the plant, and we can extrapolate how the environment affects those phenotypes, that also means that we can work backwards, which means that if we have a plant and we know its genome, and we know in the real world how it's been expressed, that is going to give us a lot of environmental information. And it's going to allow us to start making better decisions about what we do with our crops in the real world, as well as in these controlled environment situations. And that machine learning takes us to the next stage of this, which is who is going to be farming in the future. This machine learning is going to make it possible for us to build relatively small, flexible systems that in many ways are going to take the guesswork out of farming and really put people in the driver's seat in a way that they never have been before. They're going to be able to interact with their plants on a very deep level and get a high level of plant science understanding without having to be a biologist, you know? And the thing is that this paradigm is going to affect everything. You know, when you start talking about changing not only who produces food, but where you produce food, that's going to have a drastic effect on the infrastructure across the board. You know, from everything from how we deliver that food to how we confirm that that food was produced in the manner in which we expected it to be produced, and how it got to your house. And that's one of the areas that we're actually going to see things like blockchain become incredibly important, because a farmer is not only going to be able to show that they are using this machine learning and these high level algorithms to produce the best crops, but they're going to be able to show their consumer that they're doing this in the most environmentally and friendly way, and that there's the least amount of hands between them and their food as possible.
Awesome. So I'll just finish this up here. Let me get back to my notes. So the future here, we are thinking is an improved user experience, is what Nathan just kind of touched on. So think about internet and smartphones created new opportunities to share interesting and important and consumer relevant information. We have these social media platforms. I have this example here. During COVID, there was farmers in China couldn't sell their produce at markets. There was excess produce in cold storage, and transportation was halted. The Sky Brother pomegranate, for example, turned to China's version of TikTok and was able to sell directly to consumers, earning $46 million in sales in 2020, and in one instance, 6 million won in 20 minutes. And more than 100,000 farmers streamed 2.52 million sessions on Alibaba's group Taobao Live. But they had to rely on logistics supported by the streaming platforms themselves. So this is kind of getting into what Nathan was just touching on, where the entire infrastructure is could potentially be changing with the direct connections that we have from our smartphones and from the internet to the people who are producing our crops, and likewise back from the people who are producing the crops to directly to the consumers. So we're looking at we're thinking about how to design features and software features that drive revenue and cut costs, because farming is about selling and selling is about information. So that's where Nathan is talking about blockchain, for example, being able to authenticate and trace products from their original source, and then being able to show why that product is better. That's the Instagrammability that I'm mentioning there. So in terms of like consumers, they're starting to care a lot more about the provenance and the authenticity of the ingredients and the claims about those ingredients. So being able to incorporate that from a CEA perspective allows you to control more of the data that consumers potentially care about, and have less complexity when you're trying to authenticate and trace products throughout the supply chain when those supply chains are shorter. But let's see, I got a minute left before I want to get to the conclusion slide here. So there's the gamification element of this as well. So being able to display where these farms are located and display where the produce is ending up in a way that incentivizes people to go to a restaurant that has produce that's sourced by a particular farm and express their values that way is something that we're working on, and we think is at the forefront of where the industry is headed. not just displaying data about how consumers, express their opinions and the connection between farmers and consumers, but also the displaying of the data that in a way that makes sense to people who have never farmed before and are getting into farming for the first time. How do they view this data about vapor pressure deficit and all these different metrics and data that's being collected, and then take action in an informed way that allows them to make more money. So we could talk more about this, but 5 minutes, let's wrap it up.
Yeah, so this is one of the things that's most exciting about to me, right? I can go to Five Guys today and know what state my French fries is coming from. But what I really want to know is who grew them. Did they use drip irrigation, the most sustainable irrigation that they can use today in order to water them? The more detail I know, and probably the more quality I'm going to see, the more I'll be willing to pay. And if we can get some of this money back to the growers, right, instead of the middlemen, then I think that's going to be, really rewarding the people who are taking the biggest risk in this whole chain. And we got a couple questions here, and the first one is CEA getting more young people involved in farming? And are you working with, or is the industry working with universities to help fund that education? I know we talked about even schoolyard gardens yesterday, and how that might pay off. So maybe you could talk a little bit about that right now.
Yeah, so there's a lot of programs that are popping up, from like the farm to school program. There's also like career technical education funds that are out there at the high school level, for example, to train kids to understand what's going on and develop applicable skills in this field. Right now, in terms of like ag programs that exist at high schools, they're really focused on like pipe repair or welding, and not so much on software and technology. But companies like ours, and there's a lot of others out there that are engaging with the discussions with schools at the collegiate level, but also at the high school and even at the elementary school level, to start training up kind of the farmers of the future and exposing them to the new tools that are emerging in farming. I think that's good. Great. I'm looking at some of these other questions. Right to repair. Do you want to take or you can ask the questions in the order that you think is best? Sorry.
Yeah. So someone's asking, are you familiar with right to repair laws conventional farmers are being faced with? And do you think there can be a point where there's too much computer integration? And I'm not familiar with the term right to repair. If you are, could you explain that as well?
So right to repair laws, and I'm not super familiar with this, but I think it has to do with whether a private company who didn't install the system can repair the system, or repair a piece of the system. I'm not sure about how that is affecting conventional farmers. Maybe like if you had some John Deere product or something, you can only have John Deere fix that product. In terms of there being too much computer integration, I think the value here and where we get around any kind of right to repair laws is there's a big movement toward Web3 and decentralization. The most important thing is the decentralization of knowledge. So if we were able to put the right knowledge out there, then the consumer or the farmer can make the choice about whether they want to go with this company or another company. And maybe one company says, this is a standard system, anybody can fix it, and that's why the farmers or the modern farmers are going to go with that system. I don't think that there's too much computer integration at this point. I think that we just don't know what to do with all of this data. So it's kind of making sense of the data that is the big issue in this space.
Yeah, then we have another, thank you, that's a good answer. We have another question here about how do you see organic farming using controlled environments?
Ben, that's you.
So organic farming is prime for controlled environments. First, with controlled environments, a a major possible feasible output that we have for it is efficient breeding. So we're moving away from GMO, which on the definition level of a GMO, it is a lab modified seed or product. So rather than lab modifying something and artificially modifying it, we can take landrace breeds and we can harden them in a controlled environment agriculture to then actually propagate them outside again as well. And with that as well, because we are doing controlled environment agriculture, we can alter and control that environment in a way where we do not need to use pesticides, chemicals, or GMO seed for the production of that growth. So really organic farming should be drooling over controlled environment agriculture is the easiest answer for that.
Yeah, interesting and great. So then we have one last question here before we do the conclusion. And this question has to do with a normal farm versus and a tractor braking on a normal farm versus a computer braking on a CEA farm. And it's really interesting. My boss, Eric Olson, is always pushing us to be more creative on making sure that we've got the most reliable products, because oftentimes our customers are 4 hours away from a supplier, a 4-hour drive. So things have to work and they have to be reliable, because a 4-hour drive each way, is just not attainable. So what about this situation, right? In this question about, does it take more time to fix stuff on a CEA or shorter, and how does that affect production?
Yeah, so I think the answer that I want to give here is like, it depends on the companies that are involved in designing these systems. So if you have a kind of a big, the best example that I can give is like a Raspberry Pi, for example, which is just an off-the-shelf computer module. It's really cheap. And a lot of industry, and I know of an example from one of our other engineers was telling me, there was I'm not exactly sure what the industry he was in, but it was an industrial operation, and he replaced all of his industrial operation, like computer brains, with Raspberry Pis, and he was able to put 4 different Raspberry Pis in a line, and if one went out, the other one would just take over, because it's so cheap and technology is developing so quickly. And there are companies like Raspberry Pi that are putting out products that have enough computing power that you would need, and are relatively cheap and inexpensive and easy to replace. I think it's very different than if you're trying to repair a tractor, for example. A tractor is really specialized. It's only used for farming. A Raspberry Pi is used in all sorts of different fields, for industrial control or just hobby projects or whatever. So being able to design operations with that in mind of, I'm going to design these facilities and use these parts that are easily replaceable or, or cheaper, but serve the same purpose, I think is where the industry should be heading. And this is also important for teaching people about how to use the technologies that are in the industry. If it's just a big company like, Samsung that is producing these really specialized parts, and they're the only ones who do it, it's kind of hard to train students or people who want to come up in the industry to use those parts, because they're expensive and they only come from one company.
Great points. So, and then I do have, want to ask one last question. I had this question as well. Can you point to some specific successful CEA examples that maybe we know of or would read about?
I have probably a different answer than Ben, but Ben, you go first, and then I'll go off of that.
Sure. I'm going to go with 2 that are kind of on opposite spectrums, but both very cool. So there's one in Brooklyn called Square Roots. It's actually founded by Kimball Musk, Elon Musk's brother. And those are module CEA units that are being used with shipping containers. So they purchase shipping containers. They are in Brooklyn. They're also in the Midwest as well. And they have been very successful in CEA agriculture. They supply it to some of the top restaurants in New York City and in the New York State, along with local grocery stores and farmers markets. They are carried often through Baldor, one of the largest food distributors on the East Coast. And then most of their labor is younger generation college students who are looking for easy, accessible jobs, who did not think that agriculture would be the career they were going to go down until working for Square Roots. And then the other one is called Pasona Urban Farm by Kona Designs. It's in Japan. It is in the middle of Tokyo. It is actually a recruitment company's office that is also a full multi-tiered CEA. They grow anywhere from pumpkins to they have a rice paddy field in their lobby. They grow broccoli, spinach, and all the produce that they grow there is used to feed their employees, and their employees are also allowed to take it home with them.
Wow, great examples. I love that. So, Ethan, you had a couple as well?
There was one that's in Wyoming. I think it's called Vertical Harvest. I think the reason that one is a model, I guess, is they employ people with physical or intellectual disabilities who want to work in vertical farming. This is kind of what I'm saying about the transition from seasonal kind of unskilled labor to more skilled labor. Is what are the skills that people can attain and apply effectively. And I think this CEA really opens it up to being able to hire people that may have more difficulties getting jobs in other fields, because there's a lot of assistance from computers, machine learning. It's a controlled environment. You're not out in the 100-degree heat in the summer picking grapes or whatever. So there's opportunities there to bring in new people. I think that is a model that could be looked up to. But what I was going to say that's different than Ben is, I think the right models are still emerging. And the Aero Farms SPAC went through for reasons that we can speculate on, right? But it may not be the right solution may not be out there yet, because the traditional farming isn't as involved as they should be to take the industry to the next level. It's kind of like the Silicon Valley crew coming in and putting a bunch of tech into this stuff, and then not understanding the unit economics or what it takes to actually run a farm. Like wastewater is a big thing. If you look up some of the farms or some of the CEA operations or projects that have had issues with that, I think farmers right away would know all the issues with water and that they would plan a different facility. But we haven't so much seen that yet. So hopefully we see it very soon here. I think the time is right. Probably within the next couple of years, we'll see larger bigger farming, traditional farming operations coming into the CEA picture and designing very different facilities.
Yeah, great examples. Thank you. So final thoughts here, Ethan?
Yeah, this was just a wrap up. It's mainly for Ben. This is that we kind of did the summary with these questions. I don't know, Ben, you want to just run through it real quick?
Yeah. So very quick, my chef speedy talk. So with CEAs, we see a feasible route towards returning to holistic practices. And I think that's something that, Ethan was mentioning very well with sort of the evolution of CEAs and the examples out there right now. The huge issue that we have is the narrative behind agriculture and what is traditional and holistic agriculture versus what is commercial agriculture, and how do we merge those two in these modern times where we have such high demand for sustenance. And so I think CEAs offer a feasible route towards returning to holistic traditional farming practices on a commercial scale. The right tech is out there. And now it's really, as we were just saying before, it's about finding and understanding the applications with the tech that exists now. Like I said at the very beginning, originally with a lot of these farming and landscaping agricultural methodologies, it was very science fiction leading into the 2000s. Now, with the massive developments in tech in the past 20 years, this is becoming feasible. We just need to be open-minded enough to see how to apply that tech. The next generation of CEA uses intelligent, not smart hardware. And that is a good one that sort of responds to the equipment issue of it. Smart hardware is something that is just connected to the internet pretty much. Intelligent is, we are talking about artificial intelligence, we're talking about learning algorithms, adaptive systems, which is an advanced form of mathematics that allows the formula to adjust and adapt as it gets more variables. This is going to create endless efficiencies that is a tool to the farmer. It's not making the farmer give up control of it. It's optimizing the farmer's own personal understanding of their systems. And it will help them prevent and lower risk in their growth operations. The key to CEA's future is converting knowledge, data, logic. We are a global market in all truth and reality now. It is a very different world in agriculture. We are not just microclimates, we are a macroclimate made up of microclimates. And there is a whole new language that needs to be written for us to understand the regulation, the standards to be set for agriculture that exists today, and how we can be open sourced and truthful about that. So CEA, especially with the use of blockchain and with data collection, offers a road forward to create a universal language for the future of agriculture.
Yeah, see, I told you these guys were bright. Definitely a lot of really interesting information to supply us. Great job today, guys. What I really want to do is have you back in a month or two and even do a deeper dive into some of the specifics that you covered. I think that would be really fascinating and really helpful to everybody. But I got to tell you, you guys were fascinating and great. And thanks for joining us today. I want to say to all our viewers, thank you for checking in today. You got a wealth of knowledge here from Ben and Nathan and Ethan today. And you can see all our trainings, at the janesusa.com/trainings page. Over 150 irrigation trainings exist there today. You can listen to this webinar as well as all the others wherever you listen to your favorite podcasts, right? We convert these all to podcasts, and I just love it that people are driving around during their workday, listening and educating themselves and, being better. And that's really great. So anyway, thanks everybody. I hope you guys have a great weekend, and we'll see you here next week for a couple more trainings. So thanks again, you guys.
All right, thanks. See you.
Thank you.